Hi. So we're going to continue working on our discriminant and our quadratic formula. So here they're asking, does the discriminant give the exact roots of the quadratic equation, the points where the parabola crosses the x-axis? Our answer for this is no. It only tells you how many you have. The quadratic formula will give you the exact roots. How is the discriminant related to the quadratic formula? So if we remember, our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Our discriminant is b squared minus 4ac. That's what's underneath our square root. So that is how it's related. They want to know, explain why, if your discriminant is positive, there are two roots. Remember, we have plus or minus. So that's why. Because we're going to have, if it's positive, plus the square root of our b squared minus 4ac. But we're also going to have minus the square root of our b squared minus 4ac. If our discriminant is equal to 0, there's only one root. Because if you have something, let's say we have our b, negative b plus, let me put the negative b there, negative b minus 0, minus the square root of b squared minus 4ac. So if we have negative b plus the square root of 0, that's just going to give you negative b plus 0, which is negative b. If you have negative b minus the square root of 0, that's just going to give you negative b minus 0, which is just going to give you negative b. You end up with exactly the same number. That's why there's only one root. If your discriminant is negative, there are no roots. Rather, there should be no real roots. Because remember, that's going to give you the square root of a negative number, which that is imaginary. So, they want you, for the examples below, to find the discriminant, determine the number of roots, and then use the quadratic. There should be no real roots. Then use the quadratic formula to find the exact roots. So here, in this example they give us, our a is 1, our b is 3, and our c is negative 4. Our discriminant is b squared minus 4ac, which is going to be equal to 3 squared minus 4 times 1 times negative 4. That's going to end up giving us 9 minus, which is going to turn to a plus since we have a negative times a positive is a negative. Negative times a negative is a positive. 4 times 1 is going to give us 4. 4 times 4 is 16. Our discriminant is going to end up being 25, which is a perfect square. So we're going to have two real roots. And since it's a perfect square, they're going to be rational. We just have to write two real roots. With our quadratic formula, remember, it's x is equal to negative b plus or minus the square root of our discriminant, b squared minus 4ac, all over 2a. So we can skip a little bit of steps because we already know what our discriminant is going to be. We know it's going to end up being 25 under our radical. Our b is positive, so the opposite of a positive is a negative. And we know that 2 times 1 is going to end up being 2. So we can make this x is equal to -3 plus or minus the square root of 25 all over 2, which is going to simplify to -3 plus or minus 5 all over 2, which we're going to split into two answers. One answer is going to be -3 plus 5 over 2, which is going to equal positive 2 over 2, which is going to equal 1. The other answer is going to end up being -3 minus 5 over 2, which is going to end up giving us -8 over 2, or -4. So what that's telling us is our two answers for number 4 are x is equal to -4 and x is equal to 1. So that's with that question. With this question, we can see that our a is 2, our b is 4, and our c is 1. Our discriminant, which is b squared minus 4ac, is going to be equal to 4 squared minus 4 times 2 times 1. So this is going to end up giving us 4 squared is 16 minus 4 times 2 is going to give us 8. 8 times 1 is 8. We're going to have 16 minus 8 is 8. It's positive, so there are going to be 2 real roots. Again, our quadratic formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to shortcut this a little bit like we did in the last one. So our b is positive, so the opposite of positive is negative. We're going to end up getting x is equal to -4 plus or minus the square root of our discriminant, which is 8, all over twice our a. Our a is 2. 2 times 2 is 4. So we know that 8 is the same thing as 4 times 2. So this is going to give you the same thing as -4 plus or minus the square root of 4 times 2 all over 4, which is going to give us -4 plus or minus the square root of 4 times the square root of 2 all over 4. Our square root of 4 is 2. We're going to get x is equal to -4 plus or minus 2 square root of 2 all over 4. If we want, we can simplify this a little bit because everything here is divisible by 2. So we can divide -4 by 2, 2 by 2, and 4 by 2. If we do that, we're going to end up getting a simplified version of -2 plus or minus the square root of 2 all over 2. So that's going to be our two answers. One's going to be plus and one's going to be minus. I'm not going to worry about it too much. Let me box my answer over here. We're going to have -2 plus square root of 2 over 2 and -2 minus the square root of 2 over 2. That's going to be our answer there. Here they're asking us to do the same thing. So we can see that our a is 5. Our b, remember our b is our x term. We don't have any x term here. So our b is going to be 0. Another way we can write this is 5x squared plus 0x minus 3 is equal to 0. And we can see our c is -3. So our discriminant, b squared minus 4ac, is going to be equal to 0 squared minus 4 times 5 times negative 3. That's going to end up giving us 0 minus, but then we have times another negative, which is going to turn it into a plus. 4 times 5 is going to give us 20. 20 times 3 is going to give us 60. So our discriminant is going to be 60, meaning that we have two real roots. Again, I'm going to shortcut it a little bit. We know what our quadratic formula is. We have it 2 times here, so I'm going to, for the sake of time, skip writing it again. So when we shortcut it, that's going to end up giving us x is equal to negative 0 plus or minus the square root of our discriminant, which is 60, all over 2 times a, which is 2 times 5, which is 10. That's going to end up giving us x is equal to 0 plus or minus. If we take a look at 60, that's the same thing as the square root of 4 times 15, all over 10. That's going to be equal to 0 plus or minus the square root of 4 times the square root of 15, all over 10, which is going to be equal to 0 plus or minus 2 square root of 15, all over 10. 0 plus anything or 0 minus anything is just going to be itself. That's going to give us plus or minus 2 root 15 over 10. If we reduce it, we're going to find out that our x is going to be equal to plus or minus the square root of 15 over 5 if we divide both our top and bottom by 2. So here, they don't have the equal to 0 for us. They left it off. Remember, we need it equal to 0 for us to be able to do it. In this case, they're leaving off our c term. Our c term is 0. This can be also written as 3x squared minus 10x plus 0 is equal to 0. Our b term is negative 10. Our a is 3. So our discriminant is b squared. So we're going to have negative 10 times negative 10, which is 100, minus 4 times 3 times 0. Guess it's going to give us 100 minus 0, which is 100. It's positive, so we have two real roots. Our quadratic formula, we're going to end up with x is equal to the opposite of negative 10, which is positive 10, plus or minus the square root of our discriminant, which is 100, all over 2a. 2 times 3 is going to give us 6. So when we simplify that, that's going to end up giving us 10 plus or minus 10 over 6. So one answer is going to be x is equal to 10 plus 10 over 6, which is going to give us 20 over 6, which will reduce to 10 over 3. The other answer, we have x is equal to 10 minus 10 over 6, which is equal to 0 over 6, which is equal to 0. So we end up with one answer is x equals 0. The other answer is x is equal to 10 over 3. Here, Our A is 2, our B is 7, and our C is 50. Our discriminant is b squared, 7 times 7, which is 49, minus 4 times 2 times 50. It's negative times a positive times a positive. We're going to end up with 49 minus 2 times 50 is 100. 100 times 4 is 400. That's going to end up giving us negative 351. It's negative, so there are no real roots. So they want us to plug into the quadratic formula, but we don't have to. We just have to say there's no real roots. There's no solution. If we do plug in the quadratic formula, we're going to end up getting negative 7 plus or minus the square root of negative 351 all over 2 times a, which is going to give us 4. But because we have a negative underneath our radical, there's no real root. This would be a complex answer into the imaginary, so we can just stop right there. We'd have to move our 11 over because we want to get it back to equal to 0. So this is going to end up being 4x squared minus 5x minus 11 is equal to 0. So we can see our a is 4, our b is negative 5, and our c is negative 11. So our discriminant is going to be b squared, negative 5 times negative 5 is 25, minus 4 times a, which is 4, times c, which is negative 11. So with this, what we're going to get is we have a negative times a negative, which is a positive. This is going to give us 25 plus, when we add this is going to multiply this, it's going to be 4 times 4, which is 16. We're going to have to multiply our 16 times 11. 6 times 1 is going to give us 6. 1 times 1 is going to give us 1. When we move over, we have to add our 0. 6 times 1 is going to give us 6. 1 times 1 is going to give us 1. That's going to give us 176. This is going to give us 201. It's positive, so there are 2 real roots. So with our quadratic formula, the opposite of a negative is a positive. It's going to give us x is equal to 5 plus or minus the square root of 201 over 2a. 2 times 4 is 8. We can't simplify it. That's how we're going to leave it. So if anyone has any questions on the discriminant or the quadratic formula, I'm going to be having a Google Meet at 1, so you can either ask in Google Meet or you can post comments in Google Classroom. So if you have any questions, please make sure to ask. Thank you.